Okay, so get this. You're filling up your car, right? But not with gas, with clean hydrogen fuel from a mountain.
Hmm.
Sounds kind of crazy, right? But that's exactly what we're diving into today.
Yeah.
You send us this BBC Science Focus magazine article
Uh-huh.
called Massive New Energy Source Could Be Hiding in Earth's Mountains, and we're going to unpack all of it.
It is really interesting to think that something as, ubiquitous and sort of permanent as a mountain range could actually hold the key to a new clean energy future.
Yeah, exactly. We're talking about naturally occurring hydrogen gas, like trapped within these peaks. Now, hydrogen, we all know this is kind of like the holy grail of clean fuels. It burns clean, it produces only water.
Right.
But there's a catch, isn't there?
The catch is that most hydrogen production these days actually depends on fossil fuels, which kind of, makes it not so clean after all.
Right.
So this is really where the idea of finding natural hydrogen becomes so compelling.
So how does hydrogen even get into mountains in the first place?
Right.
The article mentions a process called serpentinization. Honestly, it sounds more like a magic spell than a geological process.
It does have a certain mystique to it. Yeah. Imagine rocks from deep inside the earth, thousands of kilometers below the surface, slowly making their way up.
Wow.
This journey takes millions of years, and along the way, these rocks react with water.
So it's like a slow-motion chemical reaction happening deep underground.
Exactly. The minerals in these rocks, think of them as the raw ingredients,
Okay.
get transformed into a group of minerals called serpentines.
Okay.
And during this transformation, hydrogen gas is released as a byproduct. So it's like Mother Nature's recipe for clean energy hidden deep within these mountains.
So these rocks are like little hydrogen factories, just churning away for millions of years.
Yeah.
But how do they even get close enough to the surface for us to access?
Right. Well, there are two main ways that this happens. One is through continents breaking apart, called rifting. Imagine two giant land masses slowly pulling away from each other,
Right.
exposing the rocks that were once hidden deep below.
So like the opposite of tectonic plates colliding.
Exactly. And the other way is through mountain formation,
Okay.
through a process called tectonic exhumation. Imagine an enormous layer cake, and someone's pushing it up from below.
Okay.
That's similar to what happens with mountains.
Gotcha.
The forces deep inside the earth push up these rocks, and over millions of years, they're exposed at the surface.
Now, the research that you sent points to mountains being far more promising for hydrogen production than continental rifting.
Right.
Why is that?
Yeah, it turns out that the environment of mountain ranges is particularly conducive to serpentinization. The cold temperatures and the way water circulates through the cracks and fissures in these mountains actually boost hydrogen production.
Okay.
Think of it like a recipe where the right temperature and the right amount of mixing are crucial for the best results.
So it's not just the rocks themselves, but also the environment they end up in.
Exactly.
The mountains provide the perfect setting for this hydrogen-making magic to happen.
Exactly. And the research team's simulations found a dramatic difference. Mountains offer 20 times more hydrogen potential compared to areas where continents are drifting apart.
Wow, 20 times. That's a huge difference. And it's not just theory, right? Scientists have already found evidence of natural hydrogen in existing mountain ranges.
That's right. There have been promising findings in places like the Pyrenees, the European Alps, and the Balkans.
So it's like the treasure map is starting to reveal its secret.
Exactly.
This is where it gets really interesting, right? We've established that there's natural hydrogen hidden within these mountains. But how do we actually go about finding and accessing these reserves? It's not like we can just drill into any mountain and strike hydrogen gold.
Yeah, it's a complex puzzle.
Yeah.
This research opens up a whole new frontier in clean energy exploration.
Right.
We're moving beyond the idea of producing hydrogen in factories and looking at the potential of sourcing it directly from the earth.
And that leads us to the big question, what's next? What needs to happen to turn this exciting discovery into a viable source of clean energy?
Well, first we need to pinpoint where this hydrogen is accumulated.
Right.
It's not evenly distributed throughout these mountain ranges.
Okay.
It's likely concentrated in specific areas.
Okay.
And to find those sweet spots, we need to understand how hydrogen migrates through these rock formations.
So it's like a treasure hunt, but the treasure is invisible and constantly moving.
It's a fascinating challenge. We also have to consider the role of deep hydrogen-consuming microbial ecosystems.
Wait, hold on. Microbes that eat hydrogen.
Yeah?
Are these little guys a problem for us, or could we somehow use them to our advantage?
That's a great question, and one that researchers are actively investigating. Understanding how these microbial communities affect the availability of hydrogen is key.
So it's a delicate balance. We need to understand the rocks, the hydrogen, the microbes, and how it all interacts within this complex underground ecosystem.
Exactly. And once we have a clearer picture of all these factors, we can start to explore the best ways to access and extract this hydrogen in a safe and sustainable way. And that's where things get even more interesting.
This is what I find so captivating about these deep dives. We start with a single article, and it unfolds into this incredible web of scientific discovery challenges and potential solutions. Who knew mountains could be such complex and potentially valuable energy sources?
It's a testament to the fact that there is still so much we don't know about our planet and the possibilities it holds.
Okay, so we've established that mountains have the potential to be these massive hydrogen reservoirs. But how does this translate to the real world? What could this mean for the future of clean energy, and what are the potential implications for all of us? We'll get into all that and more right after this.
Yeah, it really is amazing to think that the same forces that, sculpted these majestic mountains could also hold the key to a cleaner energy future for all of us.
Yeah, it really puts things into perspective, doesn't it? We often admire mountains for their beauty and grandeur, but they're also these dynamic systems that are just teeming with potential solutions to some of our biggest challenges.
Yeah, and unlocking that potential requires a deep dive into the practical aspects. So let's kind of shift gears a little bit and talk about what it would actually take to extract hydrogen from these mountainous reserves.
All right, let's get down to the nitty-gritty. It's one thing to know that hydrogen exists in these rocks, but actually accessing it is a whole different ballgame. We can't exactly set up a traditional drilling rig, on a steep mountain slope, can we?
You're absolutely right. Extraction in mountainous terrain presents unique engineering challenges.
Yeah.
It's not just about the steep slopes and the difficult access,
Right.
but also about minimizing the environmental impact.
That's a crucial point. Any extraction method would have to be carefully designed to avoid disrupting these delicate ecosystems that exist in these mountain environments.
Precisely, researchers are exploring various approaches,
Yeah.
including adapting existing drilling techniques used in the oil and gas industry,
Right.
as well as developing entirely new methods that are more suited to these unique geological formations.
So it's not just about borrowing from existing technologies,
Right.
but also about innovating and finding new ways to tap into this resource responsibly.
Exactly. And as we think about extracting this hydrogen, we also need to consider the economic viability.
Right.
Will it be cost-effective to extract hydrogen from mountains, especially compared to other methods of hydrogen production?
That's a key question, isn't it? The whole point of this is to find a sustainable and economically feasible alternative to fossil fuels. If the extraction process is too expensive or too energy intensive, it kind of defeats the purpose.
Right. The economics of natural hydrogen extraction will depend on several factors, including the concentration of hydrogen in these reserves, the accessibility of these reserves, and the cost of developing the necessary infrastructure.
It's a complex equation, and it's going to require collaboration between scientists, engineers, economists, and policymakers to determine the feasibility of this whole endeavor.
Absolutely. And let's not forget the role of governments and industry in driving this forward. Policy incentives and investments will play a crucial role in accelerating research and development and making natural hydrogen a viable energy source.
It's interesting how this discovery ties into so many different aspects, from the science of serpentinization to the engineering of extraction, and then the economics of energy production. It's like a multifaceted challenge with the potential for such far-reaching impact.
And as with any new technology or resource, there are potential environmental concerns that need to be carefully assessed.
Right. Even though we're talking about clean energy, we can't overlook the potential environmental consequences. What kind of impacts could extraction have on these mountain ecosystems?
That's where thorough environmental impact assessments will be crucial. Researchers are looking at potential issues like habitat disruption, water contamination, and even the release of greenhouse gases during the extraction process.
So it's a balancing act. We need to weigh the potential benefits of clean energy against the potential risks to the environment, and we need to ensure that any extraction methods used are sustainable and minimize any negative impacts.
And it's important to engage with local communities who live in these mountainous regions,
Yeah.
to understand their concerns and perspectives, and to ensure that any development benefits those communities as well.
It's a reminder that this isn't just about science and technology. It's about people and the places they call home.
This brings us to the heart of what could be a major shift in the global energy landscape. If natural hydrogen lives up to its potential, how might it reshape the way we produce and consume energy?
It's like imagining a whole new energy paradigm. We've been so reliant on fossil fuels for so long, it's hard to envision what a truly clean energy future would look like.
It's a paradigm shift, right? Think about it. If we can tap into these natural hydrogen reserves, it could reduce our dependence on fossil fuels,
Yeah.
leading to cleaner air and a healthier planet.
And it's not just about replacing fossil fuels, it's about the potential to create a more decentralized and resilient energy system. Imagine communities in these remote mountainous regions.
Right.
being able to generate their own clean energy instead of relying on these expensive and polluting fossil fuels.
That's a powerful vision, and it's not just about energy independence.
Yeah.
It's about economic empowerment for these communities.
It's also exciting to think about the potential for new technologies and industries to emerge around natural hydrogen. Think about the innovation and job creation that could result from this discovery.
Absolutely. This could be a catalyst for a whole new wave of green technologies, from hydrogen-powered vehicles to sustainable industrial processes.
So it's not just about energy production, it's about a potential domino effect that could transform various sectors of our economy and our way of life.
And it highlights how interconnected everything is.
Yeah.
A scientific discovery in geology could lead to breakthroughs in engineering, economics, and even social justice.
It's amazing how one discovery can spark so many possibilities, but amidst all this excitement, it's important to acknowledge that there's still a lot we don't know about natural hydrogen.
Right, it's still early days. This research has opened up a door to a fascinating new world.
Yeah.
But there's a lot more exploration and investigation to be done before natural hydrogen becomes a mainstream energy source.
So as we wrap up this part of our deep dive, I think it's important to bring it back to our listener. Why should they care about all of this? What does this potentially mean for them?
It means we're on the cusp of a potential energy revolution.
Mm.
A revolution that could have profound implications for their lives, from the air they breathe to the way they power their homes and the jobs that will be available to them in the future.
It's a story that's still being written.
Yeah.
And it's a story that everyone has a stake in. As we move into the final part of our deep dive, we'll explore some of the bigger questions and implications of this discovery, questions that will challenge us to think critically and creatively about the future of energy and the role we all play in shaping that future. It's been quite a journey today, hasn't it?
It has.
From the depths of the Earth's mantle to the peaks of mountains, we've uncovered this potential game changer in the world of clean energy, natural hydrogen.
It's a story that's, as much about scientific discovery as it is about human ingenuity and our quest for a sustainable future.
And as we move into this final part of our deep dive, I think it's time to kind of step back and consider the broader implications of this discovery. What are the big questions, the potential roadblocks, and the exciting possibilities that lie ahead?
Well, one of the most pressing questions is how this discovery might reshape the global energy landscape. We've talked about reducing reliance on fossil fuels, but what does that actually look like in practice?
Yeah, it's easy to get caught up in the excitement of this new energy source, right? But the transition to a truly sustainable energy system is going to be complex and multifaceted. What are some of the challenges that we might face along the way?
Well, for starters, the existing energy infrastructure is heavily reliant on fossil fuels. We have pipelines, refineries, power plants, and even the vehicles that we drive,
Right.
all designed for fossil fuels. Shifting to a hydrogen-based energy system would require a massive overhaul of this infrastructure,
Right.
which would be a monumental undertaking.
It's a reminder that this isn't just about finding a new source of energy. It's about transforming entire industries and ways of life. And that kind of transformation doesn't happen overnight. It requires long-term planning, investment, and collaboration.
Absolutely. And there are also geopolitical considerations. If natural hydrogen becomes a major energy source, it could shift the balance of power globally. Countries with abundant reserves of this resource could gain a significant economic and political advantage.
That's a fascinating point. We often think about energy in terms of supply and demand.
Right.
But it's also deeply intertwined with global politics and these power dynamics.
Right.
This discovery could reshape alliances and create new competition on the world stage.
It's a reminder that the transition to a new energy system is as much about political will and global cooperation as it is about scientific innovation and technological advancement.
And let's not forget about the ethical considerations. As we explore the potential of natural hydrogen, we need to do so responsibly and equitably. We need to make sure that the benefits of this resource are shared fairly and that the development process doesn't harm communities or the environment.
You're right. Sustainability isn't just about environmental protection. It's about social justice and ensuring that the transition to a cleaner energy future is inclusive and benefits everyone. We need to be mindful of the potential impacts on indigenous communities, local economies, and the workers who will be involved in the extraction and production process.
So it's a complex web of interconnected challenges and opportunities. But amidst all this complexity, there's also this sense of hope and possibility. If we can navigate these challenges thoughtfully and collaboratively, natural hydrogen could be a catalyst for a truly transformative shift toward a more sustainable future.
It's a future worth striving for. A future where clean energy is abundant and accessible to all, where we've mitigated the worst impacts of climate change, and where we've created a more just and equitable world.
It's a vision that's both inspiring and daunting, but it's a vision that's within our reach. If we can harness the power of innovation collaboration and this shared commitment to a better future.
So as we wrap up our deep dive into the world of natural hydrogen, I want to leave our listener with a final thought-provoking question. If this discovery truly reshapes the global energy landscape, what kind of future do you want to see emerge? What role will you play in shaping that future?
It's a question that deserves careful consideration. And as you ponder the possibilities, remember this. You now have a deeper understanding of this groundbreaking discovery than most people. You've explored the science, the challenges, and the incredible potential of natural hydrogen.
Use that knowledge to engage in conversations, ask critical questions, and be a part of the solution. The future of energy is in our hands, and the choices we make today will determine the world we leave for generations to come.
Thank you for joining us on this incredible deep dive into the world of natural hydrogen. Until next time, stay curious, stay engaged, and keep exploring the endless possibilities that lie ahead.